In this video, we're going to take a look at how to solve trig equations by factoring. We did see some of this yesterday, so this should be a brief review. Our first example, I see a common factor of cosine on both terms, so I'm going to factor that out, leaving me with 2 sine x from our first term, minus 1 from the second term, equals 0. Setting each piece equal to 0, this is our zero product property. We have cosine x equals 0, and we have 2 sine x minus 1 equals 0. Solving our first equation, where is cosine equal to 0 on our unit circle? We think of those 4 corners where the unit circle intersects the x and y axes. So we have a point out here, 1, 0. Cosine is the x coordinate, so that doesn't work. Up here we have 0, 1. Since cosine is the x coordinate, that will work, pi over 2. Our other solution will be down here at 0, negative 1. And that would be 3 pi over 2. We're also going to learn how to solve completely, meaning giving all of the solutions to this equation. So thinking about the period of cosine is 2 pi, we simply add 2 pi, and we use the variable n to represent any multiple of 2 pi. So again, you can go around the circle in a positive direction, you can go around in a negative direction, but as long as you're making that complete rotation of 2 pi, you will get the same answer back that you started with. Looking at our second equation, adding that 1 to both sides. Dividing both sides by 2. And looking on the unit circle, where is our sine value equal to 1/2? Sine goes 1, 2, 3, so that would be at pi over 6. Plus the 2 pi n, the period for sine and cosine is the same. Sine is also positive in the second quadrant because it is above the x-axis, sine being our y value. So we have x equals 5 pi over 6. And again, plus the 2 pi n. So that adding the period plus a variable like n gives you the complete solution for these equations. Our second example, I'm seeing the same thing. I've got a common factor here. So I'm going to take out the tangent, leaving me with root 2 times cosine x from my first term, minus 1 after I divide out that tangent equals 0. Setting each piece equal to 0, we're looking for where does tangent equal 0? And where does the square root of 2 times the cosine of x minus 1 equal 0? First of all, looking at tangent, remember tangent is sine over cosine. So we're looking for where is the sine value 0. So we have 0 divided by another number. Out here at 1, 0, our sine value is 0. So that would be at 0. The period for tangent is only pi. Remember, tangent is positive, negative, positive, negative. So it repeats more often than the sine and cosine functions do. So when we're solving completely, we need to make sure we have the correct period for each function. Of course, simplifying, 0 plus pi n is just pi n. And sine is also 0 over here at pi. So the other option would be pi plus pi n. But of course, if you add pi to itself, really this is the only answer that we need. It includes pi plus pi n. Solving our second equation, adding that 1 to both sides. Dividing by the square root of 2. and then we'll have to rationalize so that this looks like a unit circle value. So when we rationalize, we're going to move that radical up to the numerator and simply drop it in the denominator. So whereas cosine root 2 over 2, that would be at our 45 degrees, or pi over 4 in radians. Adding the period of 2 pi n. Cosine is also positive in the fourth quadrant at 7 pi over 4. And again, adding that 2 pi n. Last example, first thing we want to do when we are solving is get it equal to 0, especially if it looks like we might have to factor. So I'm going to subtract that 4 from both sides. We get secant squared minus 2 times tangent minus 4. And as you can tell by the title of this slide, notice that we do not have the same trig function. It looks kind of like a t-chart, but because secant and tangent are different functions, we can't set up our t-chart just yet. So we're going to replace our secant squared with its Pythagorean identity, tangent squared plus 1, keeping the rest of our equation the same. Combining like terms, we can drop those parentheses and combine the 1 with the negative 4. And then we can set up our t-chart. What multiplies to negative 3 adds to negative 2. We would be multiplying negative 3 and positive 1, and those would also add to negative 2. So now we can use our zero product property, set each piece equal to 0. And tangent plus 1 equals 0. Solving our first equation, we have a value that is not on the unit circle. So we'll use our calculator for that one. Remember, what we're really doing to get x alone is we're taking the tangent inverse of both sides. So when you punch this in your calculator, make sure you are using the tangent inverse function, and make sure that you are in radian mode and not degree mode. If you're not sure how to change the mode on your calculator, we can take a look at that in class. So I got an angle of rotation of 1.249 radians. Again, adding that period of plus pi n. So for tangent, as you may have noticed on the last one, we really only have one answer because of the way that the tangent repeats itself on the unit circle. Unlike sine and cosine, which are the same sign in adjacent quadrants, so for example, sine is positive in 1 and 2, adjacent means next to each other, and cosine is the same in 1 and 4, those are next to each other. Because tangent is the same in, for example, quadrant 1 and quadrant 3, that adding the pi n will get us back to where we need to each time. So for tangent, we only need that one answer. Looking at our second equation, subtracting 1 from both sides. Where is our tangent equal to negative 1? This would have to be where sine and cosine are the same value, but opposite signs. So sine and cosine are the same value at pi over 4. They're both root 2 over 2. But of course, they're positive in the first quadrant. So we would have our cosine value being negative in the third quadrant. So that would give us a 3 pi over 4. Plus pi n, and that will give us the entire solution that we need, because if you add pi n to the 3 pi over 4, if you rotate that half a circle, you'll land in the fourth quadrant where cosine is positive and sine is negative. And then of course adding the pi again will get you back to the second quadrant.